Welcome, everyone. We're going to start with some introductions before we get into our story today. My name is Chancey Fleet. I am the Assistive Technology Coordinator at the New York Public Library, Andrew Haskell Braille and Talking Book Library, where I founded and run the Dimensions Lab for the free and open creation of tactile graphics and 3D models.
Hi, everybody. My name is Sherry Wells Jensen. I am the NASA/Library of Congress Chair in Astrobiology for 2023. And what that means is that I am in residency at the Library of Congress with NASA funding to study the questions of disability in space and human factors in spaceflight.
Hi, my name is Danielle. I work with the American Printing House, APH. I am a member of the eBraille Tactile Graphics Task Force. I'm co-chair, where we are talking about how to standardize putting Braille and graphics onto a dot array. And I am a community and outreach coordinator for the Enhancing Abilities Lab at Cornell, as well as doing some Braille and tactile literacy education at the Andrew Haskell Braille and Talking Book Library.
Hi, my name is Lauren Ray Schaefer. I'm from the NYU Ability Project. I'm an accessibility designer. I was previously a designer on the Twitter A11Y team, and I also research accessibility design at NYU. I'm not hearing your audio very well.
Hi, everyone. My name is Marco Salsicha. I'm a senior native mobile accessibility coach with DQ Systems. And I'm here today as a tactile artist and a blind developer, and here working on the with SVG coding for this the Astra Access flight that we'll be talking about today.
So one of the things that we want to start off with first is, so how the heck are we talking about zero-G flight? And what is Astra Access, which is the organization that I work in? I am co-flight ops lead for Astra Access. And let me just start you back with a couple facts. So one of the unfortunate things that we know is only 2% of the PhDs that are earned in STEM fields are earned by disabled people. This is underrepresentation is not even a good enough word for this. It's remarkable. We'll just leave it at that. And so in order to get where we need to be, we need to do all kinds of STEM education advocacy, starting at kindergarten and going all the way up through high school and through college and into professional and formal degrees in all the STEM fields: engineering, physics, astronomy, all those good things. And once you get to the top of your field in science, sometimes the thing that you need to do for your advancement, for the next thing, the next natural step in your profession, is sometimes you want to fly a payload to space. And that might sound like kind of a far out thing, given that only 600 human beings have been in space so far. But the access to space is opening rapidly. Space is being democratized. In the next 20 or 30 years, all kinds of people are going to go to space. Currently, there are a lot of rules on the books about who gets to go to space and who does not. And those are based on the designations and the choices that we made in the late 50s and early 60s. And what we thought then was the only people who could handle the rigors of outer space were basically fighter pilots with a lot of additional training. This is just, sorry for the pun, but not going to fly. We cannot allow some of the best opportunities in the world for science and some of the most exciting vacations, not going to lie, that's going to be a thing, to be limited only to able-bodied people. If humanity is going to space, disabled people are going to. There are two factors that hold us back. One is just the general attitude toward disabled people as being risky and difficult and and just kind of a big problem. These are stereotypes that we have of the abilities and gifts of disabled people. Disabled people are generally strong, capable, and wicked good at figuring out how to handle novel situations. We do that every day. That's a thing we're very good at. That's a thing that's really necessary in space. So we can change those attitudes, and we're working on that. We all are doing that work. But another thing that we really need before we can get to space is some data. So how will a blind person, for example, stay oriented if there is no up and down? How the heck are we going to find our way around that as a blind person? How the heck am I going to do that? If you are a wheelchair user and you have paralysis, what are you going to do with your legs in microgravity if you don't have any voluntary control over them? Are they just going to float around on you? Is that going to be a problem? Should you sort of tether them together? What should you do? So Astra Access is a nonprofit organized for the specific purpose of figuring out these data questions. What we want to do is both work on the problems of, of attitudes, but our primary task is to start examining all the questions about the data, all the how-tos, all the how do we make space accessible questions. These are real questions, and I'm actually speaking to you right now from a space conference where these questions are being taken very seriously by not only NASA, but leaders in the space industry. So this stuff is going to happen, and we need to figure out how it's going to happen and how how we're going to make this stuff accessible and how we can help out. So the question that I came to the team with was, how are we going to stay oriented in zero gravity? I thought maybe tactile graphics deployed in various places around the space vessel might be the way to go. We fly on zero-G parabolic flights. That's where we test things. So our prototypes get tested in little bouts of zero gravity aboard a modified 727. The plane goes up, it accelerates upward, and on the dive down, everyone in the cabin experiences about 20 seconds of zero gravity. That's one of the main places that we test our work. And we thought we needed some tactile graphics. We needed them fast. We needed them done well. And so that's how I ended up in Chansey's lab.
So to zoom out a little bit, back in 2016, I was approached by a blind person who's pretty well connected in the community, moving to New York City. And he said that he wanted a tactile map, which, for those of you new to this, is essentially a raised line map of the 5 boroughs and their waterways and how they relate. And it shocked me to my core to realize 2 things: that I didn't know where to find such a simple map, and that I had been going through my life as a technologist, as an educator, and as a human without ever really noticing how low my access and library patrons' access to images non-visually really was. Many of us have seen tactile graphics at conferences. We might come across various processes for raised line drawings in a textbook associated with standardized testing. But most of us don't find a straight path from our curiosity, our interest, our self-direction to the images, graphics, and charts that would satisfy that curiosity, help us learn, help us communicate and grow. I founded the Dimensions Lab with internal NYPL innovation, a grant, and lots of help from my team and from our very wise community of practice. And we kicked off back in 2017. Our premise is simple but new. We equip blind people, low vision people, and sighted allies with the means of production to make tactile graphics, with a community and mentorship and skill building on how to create tactile graphics and which practices are helpful, and the ability to work on individual projects without regard to a professional affiliation, a particular walk of life, particular background experience, or a particular budget. So folks come in from museums and cultural institutions, but also families, also people working on holiday cards, also folks that would like to explore what a tattoo design looks like before they make that big commitment. And so the Dimensions Lab is a place where anyone can come in, use these technologies that in many cases have been around for decades, and I'll tell you more about the printing processes later, learn what they need to learn, explore, feel well supported in non-visual, accessible techniques, and leave with the individual projects that they want to do. Traditionally, tactile graphics are extremely tied to compliance and institutional priorities. And the impact of that is that we are less able to pursue our passions and our aptitudes sometimes when spatial information is involved. And that is a cycle that we want to break. We want to end the cycle of image poverty create a world where folks can have tactile images under their fingers every day if they want, explore the proposition that images are for everyone and that blind folks are as capable as anyone of understanding and, yes, producing spatial information, and that when we have the right tools, we can all compete on terms of equality and we can all excel in the arts, in STEM, and in all the many pursuits that involve communication around non-textual and spatial information.
Hi, my name is Danielle, and speaking of tools, I'm going to show you and talk about one of them. The first one that we used in our designing process for these graphics. Before you can do any sort of polished image or polished project, it often helps to have something to make those super, super, super rough drafts, the pen to paper. And the equivalent of pen to paper that we've been using is called a Sensational Blackboard. And it was really good of us to be able to use this because the immediacy was there. So as soon as something was drawn, we could look at it, we could touch it and figure out what we wanted to change on the fly. And there was no delay at all. It was just as effective as sighted folks having access to a pen and just a little notepad. And speaking of pen and notepad, that is basically what we use here, along with the addition of this Sensational Blackboard. This has a sort of rubber feeling surface, rubber and silicone, and it is backed with a plastic. And so it has a nice stiff surface. And all you have to do to make this work is I literally just have a piece of notebook paper that I'm going to put on top of the blackboard. So I'm going to line it up. And I just have in my right hand, I have a ballpoint pen, just a regular, nothing special about it, pen that I think I stole from a hotel conference, something. And I am drawing backwards. So it is not going to be very pretty, but all you really have to do is just trace on the paper what you're wanting to draw, and you can feel it a little bit. So I just drew a little kind of wiggly spiral shape just to kind of demonstrate the efficacy of the drawing, and you can feel it on the front side, but where you can feel it even more, where you cannot see it, is on the back side of the paper. So I just turned the paper around and put it back on my blackboard, and I'm feeling the more raised imprint of my little squiggly, spirally, curly line thing and this was how we started making our graphics. And so we knew, because Sherry had kind of given us an idea of what we wanted to draw, so we started kind of figuring out what a good system would be. And so we would just draw and then hand it off. Someone would kind of do the exact same sort of feeling thing that I just did right here and give some critiques based on what we saw. So we saw at first that, for example, that this shape was, I just drew a little oblong kind of circle deal, was way too big, for example, and we could just immediately bring this down a little bit. And so that's kind of where we started with that. And then we were able to shift our way from that into some more digital methods.
Thank you so much, Danielle. So the team drew out the symbols that they wanted for the arrows that pointed to the emergency exits and which way gravity was pointing, using what's called drawing film and the sensational blackboards that Danielle was doing a demo of. So we needed to get these drawings from low fidelity drawing film and sensational blackboard drawings to higher fidelity swell form paper that was a bit more polished and a lot more durable. So I took out a caliper and I measured the dimensions of each one on the drawing film. And then I used Illustrator to render them as vector graphics, inputting my caliper measurements. So I chose an 8-point stroke for the gravity arrow to make it the most prominent and easy to find tactually on the page. And then I used slightly thinner strokes for the emergency exit symbol and the dotted leader lines that pointed to it. So now we had this set of symbols that could be combined in numerous ways, depending on direction and proximity of the emergency exits. And so that we could iterate on them, we printed them on what's called swell form paper, which Chancey will go into detail on in a moment. But what it is, it's essentially this specialized paper that has alcohol in it. And when you add any form of carbon to the paper, whether that's black ink from a Sharpie or a printer or even pencil lead, all those areas are going to pop up in the swell form fuser. Personally, the fuser reminds me of an easy bake oven from my childhood, where you slide the piece of paper through and then that heat causes all those black areas with ink to puff up. And then the blind designers in the group could give me design feedback on the prints, and then I could go back and tweak that Illustrator file. So I'm going to describe verbally our final designs. You can also check them out for yourself if you go to tinyurl.com/makerspace-tactile. Makerspace-tactile is in sentence case. So the reason that we have a website like the Tiny URL is because it enables folks to look at resources at their own pace and in their own way. So the symbol that points towards the pull of gravity is a 1.5 by 2 inch uppercase V, where the bottom of the V points towards gravity, and that uses an 8-point stroke. The apex of the V points to a gear symbol, which is a sideways 1.25 by 3.25 inch teardrop that points in a specific direction. And that uses a 4-point stroke. The emergency exit symbol appears on either the left or the right side of the top of the V, and it's a 1/2 inch solid square. Then we have 5.5 point dotted leader lines with a 0.1 point dash and a 15-point gap, very specific, that lead from the V to either the exit or gear symbols. And so the leader line just slightly overlaps the side of the V. And this way, that junction is much quicker to find upon first touch of the tactile symbol. And it also communicates that there's something connected to the V. We also have 5.5 point vertical hash marks. Those are located at the center of the leader lines to communicate distance. So 2 hash marks mean the exit or gear is further away. A 1 hash mark means the exit or gear is a moderate distance away. And then 0 hash marks mean the exit or gear is close by.
All right, this is Chancey. I'm going to jump back in to talk about some of the printing processes that we use at the New York Public Library Dimensions Lab for tactile graphics. So our lab uses, and again, a lot of these technologies have been around for a long time, but they're usually behind a locked door somewhere in an educational institution or a publishing house. And the general public is usually not invited to engage with them. So we're flipping the script on that. We have graphics embossers. These are embossers that can produce really nice, crisp braille, but they can also emboss at up to 100 dots per inch and a total of about 7 or 8 different dot heights. We use View Plus, Columbia, and Delta embossers at the library. We did not end up going with graphics embossing in this case because we were looking for a smoother, bolder line, and we were looking for a line that would not be white on white, just embossed pixels, but would be more universally designed by incorporating high contrast and non-visual elements. So we went with the technology that Lauren mentioned, which is swell form. Swell form paper is great at producing flowing, subtle lines. We can do a lot of thickness and height gradations because it's a reaction between carbon and that alcohol in the microcapsule paper. There's no pixelation happening. We might not choose swell form for our early drafts because inflation has come for the patented swell form paper. It's about $1.50 a page. And we might not use it in situations where there's a lot of Braille heavy communication because lots of blind readers do not prefer the way that Braille shows up on swell form. But in this case, swell form really met our mid-drafting needs after we did our low fidelity prototyping with Sensational Blackboards. So we used swell form for our more polished drafts before we went to a final product. That's not all we have in the lab. I'll tell you real briefly about some of the technologies that we did not use on this particular project. We have 3D printers, and those are great for producing higher fidelity prototypes with lots of variation in height if we want, or to represent 3D objects that might be too large, too small, too distant, too delicate, or too dangerous to touch in their original form. But 3D printing can be a bit more expensive. It can be slow, and as some hobbyists in the audience will know, of all the media that we use, 3D printing tends to fail the least gracefully. So we did not go with that in this case. We also have cutting machines that can produce stencils that can then be repurposed for tactile graphics, like Cricut machines, Cameo silhouettes. We did not use that during this process. And we also use thermoform, which is basically a huge oven-like device on which you can put an 11.5 by 11 piece of paper. And on top of it, you can either put an existing tactile graphic made with a different process, or you can make a collage with materials such as cardboard, sandpaper, pipe cleaners, you name it. So it's a great way to engage if you don't want to design using a computer, but you want to design using your hands. And then we put a plasticized paper on top of that, and the thermoform machine will heat that up and at the same time create a vacuum seal, making a beautiful mold of the original tactile graphic. That technology has been around for at least a solid 50 or 60 years, still works really well. But in this case, we wanted to do our refinements using digital tools, using CAD. So we didn't go with thermoform this time around. But one of the things that we really emphasize at the Dimensions Lab, just as everyone has their individual projects and priorities and gets to make the design decisions, whether they're seasoned designers, absolute novices, or somewhere in between, we also introduce everybody to all the printing processes that exist, educate everybody about the pros and cons, and we've got a portfolio of samples that other people have left behind. And part of the fun in the design and discovery process is figuring out which printing process or processes are best going to meet your needs. So we got to pretty refined drafts at the library, but then it was time to take the project outside the library. This is where my role as a host and facilitator ended. And the final tactile graphics that actually went into zero-G parabolic flight were UV printed. UV printing is a more high-end specialized process that results in a very refined high contrast line. In fact, you can have full color if you want. It makes very bold, discernible, and durable tactile lines. And it's not a process that we have at the library. So we were able to work with Touch Graphics to create the final UV navigational tiles that were used in parabolic flight. And at this point, I will turn it right back over to Danielle and to Sherry to talk about what the team learned along the way.
So I can start. So that one of the most amazing things that we did in this whole process that was the most useful was honestly the very initial thing with the Sensational Blackboard. So we were able to talk about the designs quickly and accurately. The designs, they were messy. I was drawing them. I had not done very much drawing, and I was a little bit shocked when Chancey said, "Well, just start drawing things, and we'll see how it goes." And I had the design in my head, but I knew it was going to need to be refined. So what we did for, I don't know, several hours, right, Danielle, is I would draw things and I would hand them to Danielle and to another person who happened by, and instantly was able to get the "oh heck no" or the "yeah, do that" up down vote on the things that we were drawing, and we had a marvelous day of doing that, of draw, redraw, change, think, redraw, argue, draw. And then Lauren was there and was able to get those things digitized for us and print us out some things on swell paper and get the design into the computer for us. And we did his snag. Danielle, do you want to talk about the snag? I don't know if we tag teamed this accurately.
Hi, this is Danielle. So there were a few lessons that we learned in this process, speaking of that snag, which we'll talk about in just a second. First and foremost, as you probably have been able to figure out, the end of the story is a good one. And this process worked really, really well. And the graphics were gorgeous. That being said, we had a little bit of a bottleneck because we would go from accessible freehand drawing to asking a sighted designer with visual CAD skills if she could help us out. Thank you, Lauren, for for helping us kind of figure out what we were going to do next and how to produce it next. And the feedback, it kind of, it could feel as though for the one-sided designer who we had, that bottleneck could feel really pressuring. And for the blind designers, it could feel like we were a bit stuck and delayed by a timeline that wasn't our own. And so that kind of made it a little bit tough. We had the other thing that kind of went along with that we learned, that I touched on, was that when you're in the flow as a designer, as you probably know, you kind of want to stay in that flow. And when you're excited about a project, you don't want to have to leave that flow and lose the inspiration that you have in the moment. And so that was something we realized that this bottleneck kind of really facilitated, was a breaking of the flow. That being said, now we know that this can be done non-visually, as we're going to be talking about a little bit more. And ultimately, the biggest thing that I think we all kind of took away from this was that there are a few of us here talking about tactile graphics, but there are far too few people in the field doing this type of work. And it doesn't take a whole specific amount of experiences to start doing it. Anybody listening can do this work, anyone at all. I always say, I'm an awful drawer, terrible. For the longest time, my circles looked kind of like peanuts. They kind of had a little, it was not very cute. And I was not able to draw shapes very well. It looked like a kindergartner on a rattly school bus. And what we did, and what I'm going to make the ask of y'all to do, because there are some ways that you can get involved as well. The first is the URL that Lauren mentioned earlier, tiny.url/makerspace tactile, with the M in maker, S in space, and T and tactile all being capitalized in sentence case. And the other way you can get involved, after looking at those self-paced resources, is to contact us, contact NYPL, and be prepared to learn and be acquainted with what you don't know, and be open to listening and learning a whole lot. This field is so rapidly growing and so rapidly changing, and we're learning so much and innovating. And it is really fast-paced. It's a really, really fun ride, and just be prepared to jump in. That's kind of the way that we can get more folks involved, and we really, really need more designers here. The last little bit is about how, and this was really exemplified by Lauren's involvement with us, is that sighted designers can work with blind designers and not for blind designers, and we can have equitable stakes in that process.
I think just to add one more thing to what all the cool things that Danielle has already said, that we need allies, and we need blind designers, and we need sighted designers as our allies in this process. But what we don't need is an artificial divide between the things that the blind people can do and the things that the sighted people have to do. And we discovered that is sort of how we had our particular flow set up, and it was unnecessary. And so now we know that there are ways for the blind designers to do all steps of this process, just as there are ways for the sighted designers to do all steps of this process. So again, we can be equal, we can be allies, we can be co-designers together, and we don't have to make that artificial divide between the jobs for the blind people and the jobs for the sighted people.
This is Chancey. I do just want to point out, before we talk about how blind people can actually accomplish digital design through codes, since visual CAD programs are not accessible, that if you are a designer entering this field as an ally, we're so happy to have you. Your current design experience will be relevant, but it's important to understand some differences in the way that tactile design communicates. And we've got some resources for you in our tiny URL, but just to give you a couple examples. Tactile acuity is lower than visual acuity. We can get all the same information at the end of the day, but it's going to be delivered differently. So that means that things need to be scaled up, and that means that clutter is the enemy. For example, if you're communicating something with a map, for example, population density, political affiliation, and I don't know, income, You probably would not want to represent all of those things in several layers on one map. Rather, you would repeat the map 3 different times and depict one layer of information on each one. On that same tip, if Braille were print, it would be somewhere between a 29 point and a 36 font point. So it's really important to be concise when we introduce Braille on graphics. We didn't use graphics in Braille in this case, but it is important for y'all to know. So we're going to cut down on the amount of Braille that we include on a graphic. We're going to be intentional about where we position that Braille so that it's not obscuring or cutting too close to any individual tactile elements. And if we need to say more than there is room to say in the space that we have, we'll do a quick abbreviation and then spell out that abbreviation in a key on a separate page. Of course, tactile graphics don't convey semantic information using color, so we sub out other things for color. So for example, a couple years ago, we passed around the flattening the curve graphic, which originally uses red lines and blue lines. Rather than red lines and blue lines, we taught library patrons to interpret this graphic using a solid line for the slope without protective measures, a really bold, assertive looking, solid, attention-getting solid line, a thin dotted line for healthcare capacity, and a chunky dashed line for the slope of projected pandemic rates with protective measures in place. If you'd like to see that graphic and lots more really well-designed tactile graphics, I encourage you to Google Lighthouse of San Francisco Touching the News, where newsworthy graphics are produced by the professional team of tactile designers there on a regular basis. We tend to want individual tactile elements to have a little breathing room and distinct space from one another, so maybe a 1/4 inch of space between individual elements. We often use a write-up marker, 3 diagonal lines on the top right corner of an item to help a reader quickly orient to which side is up if it's not immediately evident. And there are lots of little tricks of the trade, but those are just a few to get you started. And it's a really interesting, what I hear from a lot of design students and professional designers and just regular patrons who are interested in arts and design, is that it can often breathe new life into your thinking about design, help you become more open to evolution in your designs, and really just shake things up and help you think about design in a different way. So it is an act of allyship, but it's also a way to open up your design practice in a way that's really exciting. And that's it for me.
Hi, everyone. It's Marco. So with all this discussion about how to actually create the graphics, and we talked about the bottleneck where blind designers and creatives are relying on sighted designers to actually create the graphics using tools such as Illustrator, Procreate, Inkscape. It came down to trying to figure out how can we create our own designs and how can we iterate them without having to go back and forth and back and forth. Again, we want to do it on our own terms and do it in our own way. And so that's where scalable vector graphics comes into play. Now, I've known about SVG for a few years. I was an animator and a visual effects artist before I lost my vision in 2014. And up until just last year, I thought I could never really design or draw or be artistic in that way again. But after meeting Chancey and seeing what was happening in terms of tactile graphics and how they were created, she turned me on to SVG, and I just kind of took it and ran with it. So essentially, for those of you that don't know, SVG is it's a vector graphic. So it's a graphic that can be infinitely scaled or shrunk without losing any quality. It's basically completely all developed around math as opposed to pixels. And using that, it's all XML based. So just understand, if you understand HTML and you understand CSS, or just a very rudimentary basic version of that, digging into SVG code itself was actually pretty easy to grasp and understand. It's just a little bit of some syntax changes here and there. But essentially, just by using TextEdit just by typing in some code, I was starting to draw again. I was able to start creating shapes, creating primitives, understanding spatial reasoning and the Cartesian coordinates throughout the canvas space of whatever I wanted to create. And all that it came down to was coming out the understanding how to manipulate the shapes and understanding how to manipulate paths, curves, and organic shapes versus static generic shapes. We started looking into multiple ways of learning SVG. There are a lot of resources online, but a lot, of course, naturally, practically, well, let's just face it, all of them are based on the visuals of SVG. How can designers use that to create really pretty icons and graphics for your websites and for your apps? Everything was very heavily web-based. Everything was very heavily visual, and it took a lot of grepping through a lot of the documentation and basically decluttering it. Like as James just spoke about, decluttering, making things simple is like a really good way to make things easier to understand. And going through the MDN documents of how they described SVG and how they teach SVG, and even through the W3C's website on going through SVG code, I've figured that it would just be good to develop a good stripped down way to make SVG documents a lot easier to understand when you're navigating them, not visually, but you're navigating them with a screen reader or a Braille display. So being able to go line by line through a text edit document or a Notepad++ document, or wherever you edit your text, we're coming up with just better ways of doing SVG that didn't completely revolve around a lot of the web interactivity or any of the illustration the illustration code that you get out of Illustrator. The first thing we noticed is a lot of the stuff when Lauren was doing the Illustrator documents, if you actually open the SVGs that are being exported out of Illustrator, it is a mess. It is not meant to be looked at. The code is not meant to be kind of gone through. It's not really all that editable. It's a lot of the code is all kind of crammed together. It's all done in like an older XML format. There's a lot of code and things you have to kind of understand and sort of wrap your head around. It's very non-user friendly. It's not ideal for reading on a Braille display or listening with a screen reader. And so that's why we ended up coming up with our own basic syntax for using SVG and taking advantage of some of the things that SVG can do that you wouldn't normally think about. For example, creating using the description tag to give the entire SVG description, but also using description tags within individual shapes to give them location. So if you happen to be looking at an SVG on a tablet or on a phone, you can move your finger around the screen with the screen reader active, and you can actually feel where parts of the drawing are and add like annotations as to where things are. So now you can interact directly with the graphic just by touching it. And of course, we also come up with our own descriptive or style guide, because again, we're not doing this visually. We are doing this in a way to communicate with a swell, with the embosser, with swell form, the best ways to produce graphics that are easy to understand at a quick glance or at a quick feel and touch. We're still kind of thinking about designs like guides and standards. I hope a lot of people, designers, kind of join us to kind of help come up with these standards for tactile graphics and kind of getting into the code. But essentially, yeah, we think about stroke weights. We have, for an embosser, you have up to 8 colors you can choose to create texture and create different dot heights around a drawing. There's so many applications for all of this, apart from just like iterating on these graphics for these 0G flights. I mean, you can do full-on artwork and illustrations, all done just with code and math. You can create circuit diagrams, architectural drawings, just or just jot out some notes. And one thing that we notice also with the drawing, like physically drawing, like learning how to draw and using the Sensational Blackboard, it really taps into more of your spatial awareness as a blind person. So the more drawing you do, the more you understand how shapes associate with each other and how they appear on the canvas and where they would appear and you can start dialing that in with the code when you're spatially designing, you're thinking about it, maybe you sketch it on the blackboard, you feel how everything relates, you come back to your code and you can type all that in, emboss it, bring it, feel what you've done, come back, iterate. And of course, using SVG, you can also use a visual interpreter where a lot of the art that I was creating, I was typing out the code, creating the graphics, and showing it to someone with vision. They would look over my shoulder. I would show it in Google Chrome. They would see what I created. I would explain what I saw in my head. They would explain what was actually on the screen. I would go back and fix like some of the mistakes that I came up with, or that accidentally put into the code. So yeah, that's kind of like in a nutshell, like what we were doing. And I ended up developing a whole study guide to help blind and low vision creatives go through and learn SVG on their own without having to go through all the MDN documents and strip out all the stuff they didn't need to know. Basically, a good way to get up and running on creating graphics that are ready to go for swell form, thermoform, and 3D printing, and anything that you do and embossing. And that's a live document. I'm editing it every time we figure out something new, and we share it with like an SVG study group. But yeah, it's been absolutely fantastic kind of figuring that out. Let's see, now we were trying this before. Should I, consensus from the group, should I try doing the screen share this time?
Hey, Marco, we're running close to time, so
All right.
can we take some questions from some folks? Is that
Yeah.
okay?
I think that's fine. I think, yeah, once you look through SVG code.
This is
Awesome.
Chancey. We have in the tiny URL, we have the code examples and the SVG final drafts. So everybody can take a walk through the code. And Marco, I believe it is commented out, correct?
You mean the original from Illustrator?
Yeah, no, yours.
Oh, mine. Yeah. Mine's, I basically recreated a drawing and simplified it down and tapped into some of the stuff that we figured out, like
That's
with
great.
the descriptions and such.
And
So yeah.
everyone, you'll find that in the tiny URL.
That is great. Thank you so much. Now we have homework from this session. It's amazing to me. I've been in accessibility for many years, and it seems like every time I turn around, there's something else. There's people like, how do I make this form accessible? And now to learn today how to make zero gravity accessible is awesome. Thank you all so much. One of the questions we have is, has there been much research or funding of developing tactile displays like for tablets and e-readers, or do you think tactile graphics will be limited to print for a long time?
Sure. This is Danielle. So it will not be limited to print. There are several sort of Braille kind of raised tactile graphics display projects happening. There will be the Monarch that the APH is working on. And there is already the dot pad. We've seen the graffiti come out from orbit before, or at least be worked on. So this isn't necessarily a brand new thing. There can always be more research and always be more funding, but there are several projects that are already in the works that are kind of trying to work toward dot arrays. So instead of being a multi-line Braille display, for example, they're looking at equidistant rows and columns of dots so that we can have graphics with equally spaced dots and not have that awkward grouping of rectangular cells. So that is being worked on quite a bit. I suspect it will be worked on for a long time, and more research and more funding will be coming, I'm sure.
Awesome, thank you. So we've got some questions. People are so excited about this. They want to know about the Dimensions Lab. And can anyone come visit the Dimensions Lab in New York Public Library, or do you have to make a reservation, or can you just drop in and say hi?
We are open 6 days a week by appointment, and folks who have had an appointment and been oriented to the lab and the equipment can subsequently make appointments on their own that are unsupervised. The first time that you visit, you'll get a tour of the lab, an introduction to various printing processes, and a hands-on orientation to the processes that you want to use. And absolutely anyone can book that appointment. You can write to me. I'm in the tiny URL, chanceyfleet@nypl.org. And you do not have to be a patron of the New York Public Library. We are a library that is committed to advancing knowledge and strengthening our communities. And we do that all over the world in some ways. So please come join us, visit us. Don't be a stranger.
Awesome. Thanks, Chancey. Have you all worked with any schools in New York City or elsewhere? You know, it feels like there would be so many potential applications of this collaboration approach in education settings.
We do outreach to schools and summer youth programs. We do work with the Department of Education, students directly, as well as families and educators. We do a lot of parts of the Dimensions Lab that are a lot less techy. So that might look like celebrating Lunar New Year with the Year of the Rabbit by doing tactile coloring and origami crafts with the kiddos so that we can start with spatial information early. And families and educators or students are welcome to come in anytime. We love supporting students and we love strengthening our community of practice and showing people how they can use tactile graphics, especially the affordable tech components of tactile graphics at home and in any classroom once they leave the library.
Awesome. Thank you. And thank you all for all this wonderful information on making zero gravity more accessible. I'm excited to learn more. In addition to the tiny URL that you gave earlier, we can also find resources on the resources page just in the session itself. So I invite you all to go there as well. Thank you again so much for being and presenting at AxCon. And we've got a whole nother day tomorrow I'm looking forward to. So we'll see you all tomorrow.
Thank you all.
Thank
Thank
you.
you, everyone.
Thanks, everybody.
Thank you.